All right, so for this question that we have been asked to factor the quadratic function, right? And when we talk about factoring, what are we doing, right? We're pulling out the greatest common factor in these factors. Are you all with me? Right now we have a quadratic function. How do I know this function is quadratic? Because the highest exponent is a what? 2. So what else do I know about this? What is it going to look like on a graph? It's going to look like a what?
Parabola.
A parabola. It's going to be a U. Is it going to U up or U down?
U up.
Is it going to U up or U down?
U up.
How do we know?
Because it's a positive number.
What's positive?
R2. X squared.
R concave.
R vertex.
Our A is positive, which is the coefficient of x squared, right? So because our A is positive, we know that this thing is going to U up. What else do I know about the graph of this function? Where is it going to cross the y-axis? How do you know it's 12? Because it's your C, which is your y-intercept, which is your initial value. Are you all with me? So what do I know? I know that I have a C. Come on, we got to remember those key features. That this is my C, which means this is where my graph is going to cross the y-axis. And then this, my A, is 2. It's positive, which means my parabola is going to U up. Now, here's the question. Let me see who was paying attention. Is my graph going to be wide or narrow?
Narrow. Between 1 and 2.
Between 1 and 2 what? Between 0, it's not going to be between 1 and 2. It's going to be at 2, right? But what did we say about wide and narrow? What is this?
A 0 number.
An A of 0, right? So wide is whatever is closest to 0, right? At what point is it no more wide and it starts to become narrow? When I am greater than 1. So anytime we have a fractional A, 1/3, 1/5, 2/9, 2/8, anytime we have a fractional A, that thing gonna be wide. Are y'all with me? But when we have a
Stop recording.
what?
Oh, I better stop recording. I'm sorry.
But when we have an A that is greater than 1, it becomes what? More narrow. Are y'all with me? Let's look right over here in front of Lanika. See where it says transformation? Everybody see that? Lanika pointed that. Right above it says transformation. Right? What does it say about A being greater than 1?
Vertically stretched.
It's what? So watch this. Here's vertically stretched. I'm being stretched vertically. That means I'm more narrow. Are y'all with me? Now, what does it say about A being less than 1?
Vertically compressed.
Vertically compressed. That means my arms are being pushed down. It's wide. Are y'all with me? So if A is greater than 1, we have what?
A vertical.
Vertical what? Stretch, which really means narrow. Y'all with me? What if A is less than 1, between 0 and 1? What is that?
Vertically compressed.
Vertically compressed, which means it is wide. Are y'all following me? Vertically stretched, greater than 1. Vertically compressed, less than 1. Here's the only thing you got to remember. If that A is a fraction, it's going to be wide. It's going to be vertically compressed. If A is greater than 1, it's going to be stretched, which means it is narrow. Is everybody following? So what things can I tell from this so far, Miss Stampley? 1, my parabola U's up. And it's going to be vertically stretched. Not wide. Wide is compressed between 0 and 1, Lanika, right? This is greater than 1, so then it's going to be vertically what? Stretched, right? Lanika, turn your body. Thank you. And then here, what is my y-intercept? 12, which tells me my graph is going to go through the y-axis at 12. Are y'all following? Yes? Now, what else can I tell? We know this tells us concavity, up or down, wide or narrow, stretched or compressed. We know this tells us where it cuts the y-axis. What does the B, because when we...
Our maximum or minimum?
Does B give us our maximum or minimum? No. What gives us our max or min? How do we determine? Say it. How do we determine if we got a max or min? If it's going to U up or what? So if the A is up, what do I have? Minimum. If the A is negative and it's down, what do I have?
Maximum.
So what determines if I have a max or a min? The A. A, and you keep saying vertex, is that your, well, it is your vertex, the maximum is your vertex, but A determines if I concave up or concave down, if I have a max or a minimum vertex. Is everybody with me? Yes? What does C tell me? Where my parabola is going to cross the y-axis. Now, what does B tell me? Because I can simplify this to what? It tells me if I have a shift left to the y-axis or a shift right of the y-axis, right? So this is going to be what?
Left.
10x. So I got y equals 2x squared plus 10x plus 12, right? What does this tell me? Is this, do I have a B? If I got a B, I already know I got a shift. Right? Now, which way did I shift? So that means I'm not sitting on the y-axis. I'm not sitting on the y-axis, because if I was, this would be a 0. It wouldn't be there. Are y'all with me? Are y'all following? The fact that I got a B tells me this thing shifted somewhere. Are y'all following? So how do I know it shifted? What do I mean by shifted? There was some type of initial velocity, right? Y'all listening? If there was no shift, it's like, we talked about this. It's like something rolling off the edge of something and just falling, right? There was no push. It just rolled off. So that means there's no B. There was no shift. But if something is thrown, there was an initial velocity, so that thing has a shift. It has a force behind it. It has a shift. Are y'all with me? It moves away from where it started. So that is a shift. Are you with me? So we have a B. We have a shift. Now, which way did we shift depends on what calculation do we do? A times B. So I look at my AB. If my AB is positive, it shifted to the left. If my AB is negative, it shifted to the right. So I'm looking at my A, which is positive. My B is positive. Positive times positive is positive. So which way did the vertex shift? To the left or to the right?
Left.
To the left. So now I got a picture of this thing, right? Use up. Has a minimum. Vertex is to the left of the y-axis. This arm goes through the y-axis at 12. Is everybody following? And from my vertex to my first point here is left 1 or right 1 up 2. Are y'all following me? Because that's that A. It tells us how far up we got to go. We go right 1 and then up what? 2. So that's where my parabola used on both sides. Are y'all following me? Yes? Now, I want to show you real quick before we solve. Nope, not before we solve it. Let's solve it. So let's go. It says solve this. What am I looking for when I solve a quadratic function? What is the solution to a quadratic function? X? Specifically, because we got a lot of X's on a parabola. What am I looking for? Specifically, what am I looking for? The points that are sitting on the
X-axis.
that is going to be called my x-intercepts. I am looking for, come on y'all, this got to be routine. What am I looking for? The x-intercepts. What else is that? My roots. I am looking for what else? My zeros. I am looking for my solutions. Are y'all following me? Let's do it again. What am I looking for when I'm solving a quadratic function? What am I looking for? X-intercepts. I am looking for my roots. I am looking for my zeros. Those are my solutions. Are y'all following me? All right, now, how do I find those, Miss Stampy? Well, we got multiple ways to solve a quadratic function. I'm going to list them real quick because we haven't done them all. But I'm going to list them real quick. What can we do? We can do a what? Table. We can also do what? Graph. I could graph this thing, plug in a bunch of X's, put it in there, plug in the X's, get out the Y, plot those order pairs, and see what I get, right? I could plot those, and what am I looking for? The point where the parabola crosses the x-axis. That's what I'm looking for. Now, what if I don't have graph paper and I don't want to do graph? What else could I do? I could factor. And that's the method that we've been focusing on, right? What have we been using to factor?
The Punnett square.
The Punnett square. We've been using the area model, right? We plug that thing in, pull out the greatest common factor. We factor it, set it equal to 0, solve. That's how we've been factoring, right? And then what is the last, or not even the last way, but the next way would be quadratic formula. That's what I'm going to teach you next. The quadratic formula is another way we can solve. And then the last way that we can solve is called completing the square. We may or may not get to that, but we will definitely have enough ways that we can use in order to solve these quadratic functions, right? So let's go back. Which one have we learned?
Graph, factor.
Graphing and what?
Table.
We did a table for quadratic functions?
Yes.
Yeah.
Well, we did it to determine if it was quadratic. Did we do it to solve it?
No.
Not really. We got to dig more into that, right? And then we got to work with graphing some more to see how that parabola looks. We're going to do that. But what are we okay with is factoring, right? So tell me what to do. You guys have been doing this, right? Punnett square? What always goes in the first box? The A term, right? A squared term. What goes in the last box? 12, right? The last number. Now, what goes in these two boxes?
It doesn't matter.
It doesn't matter.
It doesn't matter. It's either the 6x or the what? 4x. Now, what have we been learning over here in this station? In this station, for the people that have been in this station, what did we learn? What did we learn? Let's say I never gave you this, and all you had was this. How do I figure out these two numbers?
Has to add.
Those two numbers got a what?
Multiply and add.
Multiply to give you what?
12.
C. And then what? Add or subtract to give you what? To give you the B. So let me show you for those of you that haven't been here yet. I'm going to put A equals, B equals, C equals. You're doing what I'm doing. What is my A?
2x.
2. Not 2x squared. My A is 2. It's the coefficient of x squared. What's my B?
10.
What's happening?
10.
We're here. B can't be 6. Right? A squared plus B, AX squared plus BX plus C. So what's my B?
10.
It gotta be in standard form to pull your A, B, and C. So what's my B? It's 10. What's my C?
12.
It's 12. Now, watch what I do. I'm gonna write right here A times C. Everybody, do what I'm doing. Everybody. Let's go. When I multiply A by C, what do I get? What do I get? Come on.
14.
A times C gonna give me what? 24.
Oh my God.
Right? Now, pay attention. I wrote down my A, my B, my C. Then I did what? A times C. A times C. The last thing I'm going to write is D and E. Now, let me tell you what D and E are. D and E are these numbers.
What?
Y'all with me? My A, my C, my A, my C, my D and E. Are y'all with me? Now, what am I trying to do? I need two numbers that are going to multiply to give me A times C. Two numbers that's going to multiply to give me A times C. Y'all with me? Then what do I need? I need those same two numbers to add or subtract to give me the B. Are y'all following me? I'm gonna go back again. What am I looking for? Miss Stampley, they didn't give me the four. They didn't give me the 4 terms. They only gave me 3 terms. I know to put my A here and my C here, but I don't know what these two should be. Here's how I figure those out. Those two are going to be our D and E. How am I going to get those? I have to look and see. Well, these two are actually your 2 middle terms here, but we're pretending we don't have them. What am I going to do? I need to figure out what 2 numbers do I multiply to get 24
4 and 6.
and add to get my B, right? So I don't want you to give it to me yet. Don't give it to me yet. I want to show you how we find that. So watch this. Do this on your paper for me. I'm going to show you something real quick. I'm going to draw me a massive T-chart. I'm going to help you organize this information. What am I looking for? 2 numbers that multiply to give me what?
24.
12. I'm sorry, you're right. 24. 2 numbers that multiply to give me 24. But add or subtract or subtract to give me what? 10. Stay with me. They multiply to give me 24, but they add or subtract to give me what? 10. All right, so let's go. Just give me the factors of 24 only. 3 and what? Matter of fact, start out in order because this will help you. 1 and what? 24. Next number. 2 and what?
12.
2 and 12. Always do this because it'll keep you organized. 2 and 12. Is there a 3 in something? 3 and what? 8. Is there a 4 in something? 4 and 6. Is there a 5 in something? No. Now watch this. I don't got to go no further. Because what's the next number out of 5? After 5 is 6. I already got a 6. So then I'm done. Y'all see what just happened? These got to be all the factors. Why? Because I already made the 5. There's none. The next number 6. We already got a 6. So I'm good. Are you with me?
Yeah.
All right. So now I'm going to go over here. What am I going to do? I'm looking for numbers that add and subtract to give me 10. If I add 1 and 24, what do I get? 25. If I subtract them, what do I get?
23.
23. If I add 2 and 12, what do I get? 14. If I subtract them, what do I get? 10. If I add these two numbers, what do I get? 11. If I subtract them, what do I get? 5. If I add these two numbers, what do I get? 10. If I subtract them, what do I get? 2. Which of these can I eliminate? Number 1, gone. What else?
2.
3.
Can I eliminate this one?
3.
Yeah.
No. Why not?
It's subtracting it.
Because they give me a 10. Don't I want a 10?
Yes.
So then I'm not going to do that one. What about this one?
Yes.
Yes, I can eliminate that one. What about this one? No. So now what am I looking to do? I'm looking for two numbers that's going to give me a positive 10. Are y'all with me? These are all positives, so I need two numbers that are going to add and give me positive 10. This was add, this was subtract. Which ones am I going to go with?
4, 6.
4 and 6. 4 and 6, positive 4 and positive 6 multiplies to give me 10. No, multiplies to give me 24, but they add to give me 10. So I know my numbers are 4x and what? 6x. Are y'all with me? Yes? Now, in order for, Miss Simply, how do we know it's not this one? Well, because if you add 2 and 12, that means they're both positive, you're going to get what? 14. That ain't what you want. In order to get 10, you got to subtract these. That means one of your numbers are going to be negative. That means you got a negative in here somewhere. And do you?
No.
There's no negatives. So that can't be it. Are you following me? Yes? And what if you multiply negative 2 and 12? You would get negative 24. Right? How would you get 10 out of these? It would have to be a positive 12 and a negative 2. That's how you get a positive 10, because your bigger number got to be positive, right? But what would you get if you had a negative 2 right here and you multiplied? What's negative 2 times positive 12? Negative 24. Was your number a negative 24? Or was it a positive 24? So I don't want a negative. You follow me? Okay, so that's how I know it's not this one and it got to be this one. Does that make sense? Okay? All right, so then we're here. So now we just do the rest. What do we do? What do we pull here? What do we got? Tell me what to do. This is 2 times x times x. This is 4 times x, right? How else can I get 4? Good. 2 times what? 2 times x. Y'all with me? We're breaking it down. What do I do here? Give me a common factor. 2 times what? 3 times x. And this is, give me any common factor you want. What do we get? But we didn't use a 6 here. What can I use from here to help me get this? 3 times what? 3 times 4 times x. Right? Right? So now let's go. What? Yeah. Yes. What do these two have in common?
X.
They have an x. What else do they have in common?
2.
A 2. So I'm pulling out a 2x. Both of these got a 2 and an x. Y'all with me? Yes? What do these two have in common? They have an x and a 3. So I'm going to pull out a... Do they have an x in common?
No.
Oh, they shouldn't. Should they have an x in common?
No.
No, that's an error. They should not have an x in common. This is just 3 times 4, right? So then what do we have?
Exactly. Eric.
Eric. Eric! Mistakes are expected, respected, inspected, corrected. Don't worry about it. They don't know. Here we go. So what do I put here, y'all? What's the only common factor they have here? 3. So we're going to pull out these 3's. I'm going to have positive 3, right? Now, once I got that side, the rest is easy, right? 2x times what going to give me 2x squared? X. I'm going to put an x here. And that's also what we had here, right? Nope, that ain't going to work. Ooh, look at that. So what do I want to pull out of here? Because I pulled out a 3, but does it have is that the greatest common factor? We're supposed to pull out the greatest common factor. 3 is not the greatest common factor between these two. What is the biggest number that 6 and 12 got in common? 6. So instead of 2 times 3, what could we do? What is this, 6x? This would be 6 times x. And then what will we make this? 6 times 2. So then our greatest common factor here would be 6. Do y'all see how we just fix that? Y'all understand that? Yes? Why did the 3 not work for me? Because once I pulled that 3 out, what should have been left wasn't true. So that let me know I need to change this number. Y'all with me? So my greatest common factor is 6. So now I pull the 6 out of here and a 6 out of here, right? So then now what we got left? We got an x and an x left. That makes sense. Now, what do I have left over here? A 2. That's what they got in common. What kind of 2? Positive. So now, can we write it in factored form?
Yes.
What was my D? It was 4 and what? 6. So now let's write it in factored form. What's going to be the factored form? It's me pulling out these factors. What factors am I pulling out?
X plus
This
2.
and this, yeah. X plus 2 times what?
2x plus 6.
Those are your factors. Some of y'all on your quizzes pulled out, like, you gave me these numbers again. Those are not your factors. That's your product. That's what it comes out to be when we multiply. These are our factors. Are y'all with me? Yes? All right, so now what do I do? I got this. What do I do?
You could check it.
I could check and make sure I got the right thing. Let's do that. Let's check and make sure we got the right thing. What do we do?
We do distribute.
Distribute.
So we do x times 2x.
All y'all doing what I'm doing, right? You gotta do what I'm doing. Bree, pick your head up. X times 2x. What do we get?
2x squared.
Thank you, Bree.
Oh.
2x squared. No, I'm asking her to pick her head up. Keep going. X times what?
6.
That's gonna give me what?
Positive 6x.
Positive 6x. Then we got 2 times 2x. What do I get? Positive 4x. And then we got 2 times 6. What did that give me? Positive 12. Question, did I do this correctly?
Yeah.
Yes, because it gave me back what I started with. Why did I do that? Just to make sure I factored it correctly. Are y'all following me?
Yeah.
All right, now let's keep going. Let's keep going. So what do I do now?
We gotta
I
solve.
want to solve it, right? But I want to show you something before I solve it. This is factored, but it's not factored completely. Please pardon the interruption. Students factored. I need you not to miss this though. Why is it the tissues in the back? Why is this not factored completely?
Because of the 2x.
Because there's a what?
2x.
Oh, not because there's 2 x's. You start this back. It's not factored completely because I can't pull anything out of here other than a 1. X and 2, there's nothing common in that but 1.
What?
The only thing that's common in that is a 1. Is there anything you can pull? Do these two have anything in common? No. So then I can't pull anything out, right? But there's a 1 in everything. 1 times x, 1 times 2, right? So I'm saying the only thing that they have in common here is a 1. I can't pull nothing else out. But here, is there something they have in common? What could I pull out of that one? A positive 2. Couldn't I pull a 2 out of this? Isn't that 2 times x? And couldn't I pull a 2 out of this? Isn't that 2 times 3? So what that means is, yes, this is factored, but it's not factored completely. Sometimes they give you a question, Savannah, and they'll say, factor this completely. What does that mean? That means there should be no common factors left. So let me show you what that would look like. Bless you. What that would look like if we factored completely. Watch this. If I got y equals x plus 2 times, y'all see my board cutting up, ain't letting me write completely. Right? Watch this. I'm going to pull that greatest common factor out. Watch what it's going to say. Y equals. What am I doing? Because I know y'all taking notes like I asked y'all. So I'm going to make nice notes that say factor completely, so you have an example to refer to later. And don't come running up to my desk saying, Miss Stampy, I don't know what you're talking about. Right? So we're here, factor completely. Let's factor it completely. How do I do that? I can pull a greatest common factor out of here. This is 2 times x. This is 2 times 3. I'm going to pull this 2 out and put it out front. Right? So watch. What am I have right here? X plus 2. I can't do nothing with that. There's nothing to pull out of that. Y'all with me? But what can I pull out of here? A 2. So I'm going to put times 2. And what is left when I pull a 2 out of both of them?
X plus 6.
X plus what? 3. Now it's factored completely. Now let me clean it up. Watch. I'm going to rewrite it as y equals 2 times x plus 3, because don't we want that 2 out front? Remember, it's y equals a times, right, for factored form. So there go my a. And then what's left? X plus 2. Now this is factored completely. This is factored, but this is factored completely. Right? Either one needs to get you the right answer. Why? Because what happens when you do 2 times x? What you going to get? 2x. And then 2 times 3? 6. Isn't that the same thing? Except I just factored it completely. I left it so that there were no factors left in it, right? And then we just brought this one down. Why we didn't do none of that, Miss Stampley? Because what's the only number you can pull out of that?
1.
A 1. Right? You only can pull a 1 out of that. So 1 times anything is still the same number, so I don't need to do that, right? If they say to you factor completely, then you got to pull any common factors that's still left inside the parentheses out. And then I just cleaned it up. I wrote it so that it looks good, right? Now I'm going to show you something else real quick. What does factored form gives us? Factored form gives us our solutions. Isn't that what we learned? So if we write factored form, watch this. Y equals a times x minus p times x minus q. That's factored form, right? My solutions are the opposite of p and the opposite of q. What is your p in this case? Negative 3. So my x-intercept, the first one, going to be negative 3. What is your q? So this is going to be negative 2. So what are my 2 solutions? Negative 3 and what? Negative 2. If I can write this in factored form, bam, I got my solutions. It's factored completely. Are y'all following? Now, we just solved this just by looking at factored form. But Ms. Stampley, that's not how I did it. No problem. You did it using this, right? So let's do it using that. What do? If I'm looking for my x-intercepts, what do I have to change y to? 0. So I'm going to write this as 0 equals x plus 2 times 2x plus what? 6. What's my next step going to be?
X plus 2 equals 0.
X plus 2 equals 0. I'm going to set them both equal to 0. X plus 2 equals 0 and
2x plus 6.
2x plus 6 equals 0. Now what we do?
Solve for x.
Just solve. Bam. Draw your squiggly. Minus 2 minus 2. These cancel out. What do I get? X equals what? Did we not get that by looking at it? Yes. Now I'm going to go over here. What am I going to do? Subtract 6 on both sides. We're going to get what? 2x. 2x equals, and then what? Divide both sides by 2, and x is going to equal what? Damn, did we not get that right here? Same thing. This is how we solve it, by setting our each factor equal to 0. Why are we doing that? Because the solution to a quadratic function are the x-intercepts. But how do I know I got x-intercepts? Because my y is 0. So we plug in a 0 for the y and we solve. But Miss Stampley, what if it's already factored completely? If it's already factored completely, you already got an A out front, then guess what you can do? Just look at it. The opposite of this and the opposite of this are going to be your solutions. But that makes sense, because watch this. 3 plus what is going to give me 0? Negative 3. 2 plus what is going to give me 0? There you go. That's how we do that. Bree, I saw your face earlier when I was here. It was a little scrunched up. So let me talk about that. So how did I factor this completely? If I were to give you 2x plus 6, and I asked you, is this factored completely? The answer would be no. Because for something to be factored completely means it has no more common factors. Is there common factors here? Yes. What common factors are there here? This is 2 times x. This is 2
times 3.
2 times what? 3. Aren't there common factors in both of these? What's their common factors?
2.
2. So guess what I'm going to do? I'm going to pull the 2 out. You know how we distribute things in? Then I'm going to factor it out. If distributing means multiplication, then factoring means division. So I'm going to divide this and this out. That gives me a 2 out front. Once that 2 is out front, what is left?
X.
X, and then what?
3.
What kind of 3?
Positive.
Positive 3. So this is that piece factored. Right? And why does that make sense? Because 2 times x is
2x.
2x, and 2 times 3 is
6.
6. So it's the same thing. So instead of writing it like this, I could just write it like this. That's the difference. If they say factor completely, just look and make sure there's no more factors left inside that you can pull out. And if there's not, boom. Now, if they don't say factor completely, do what you've been doing. Set them equal to 0, solve. Does that make sense? Everybody good there? Yes? Any more clarification? You got to talk to me because I may not always catch your face. Does anybody have a question? Is everybody clear? Because you're going to be accountable for this. Do we understand? Yes. All right, great. So, stop that. Thank you.